All right, hello pre-cal. This is lesson 8.2, law of sines. So in this lesson, you're going to learn a new formula, which is right here. And this is definitely a useful formula. In all this trig we've been doing, law of sines, and the next lesson, law of cosines, is why we had to learn everything. So it turns out we've been doing everything with right triangles only, because that's where trig came from, right triangles. But it turns out now you can use law of sines to determine missing sides or angles of oblique triangles. What are oblique triangles? Oblique triangles are non-right triangles. They are whatever triangle you can draw, and it even works for right triangles. So guess what? From before, this is like everything had to be right triangles. Well, now we've got all kinds of crazy triangles that we can actually set up a nice little proportion and use this law of sines. So, for instance, if ABC is a triangle, we use capital letters to represent the vertices of a polygon. So capital A, capital B, capital C. And it has side lengths ABC, and those are the opposite side lengths. So if this is vertex A, the opposite side we call little a. And if this is vertex B, the opposite side we call little b. And if this is vertex C, then opposite vertex C, we have little c. So that's the common nomenclature for polygons and labeling vertices with capital letters and side lengths with lowercase letters. So that's really, really important. So then it turns out that if we have information, let's say we have information about side A and vertex A. So if we have side length and its vertex, then we can set up a little proportion. A over sine of A is equal to, let's say we have angle B and side B, or we want to find side B. Then we have, we can set up, hey, what is that missing side and sine of B? So we can set up any kind of proportion. The reciprocal is also true. So we could flip all of these things. So we could write it sine of A over A equals sine of B over B. And it doesn't matter. So the reciprocal relationship is also true. But I love this. I'm always going to circle and use opposite colors. So if you have opposites, then you can set up a law of sines proportion. And then it's just cross multiplying. So super easy, super fun. Of course, I also want to point out that the largest angle is opposite the largest side. And conversely, the smallest angle is opposite the smallest side. Good things to remember. Big angle, big side, little angle, little side. And that's important for us to realize. Now, we can use law of sines when we're given a lot of information about angles. So given angle, side, angle info, or angle, angle, side info, then we can draw these triangles and set them up using law of sines. There is one case that I'm not talking about, which is the side-side angle. And we're not going to talk about it in this class this year. Normally I do, but I also normally derive the law of sines for you, but I'm also just not doing that. So in triangle MNO, so the first thing we always want to do is go ahead and draw our triangle. And it turns out as long as you draw it, set it up properly, it doesn't matter if you put M here and then N and then O, or MNO, or MNO this way. It doesn't matter. Interestingly enough. So I'm going to call this M, up here N, and this angle O. And then it says little o is 3.1 centimeters. 3.1 centimeters. Angle N is 44 degrees. So again, we need to be in degree mode Make sure your calculators are in degree mode because they're giving us degrees. Angle O is 35 degrees. It's absolutely essential that you draw the picture. We want to find N. So where is N? N would be right here, and N is the unknown, and N is what we're trying to find. So I always start with that. I see that N is opposite angle N. So I have a side angle pair, and I have another side angle pair. Here's my angle, here's my opposite side, so that's really easy. Looking at this information, just in case you're curious, this is angle, side information. Angle, side. And you can see you just sort of wrap around, and it doesn't matter which direction you go, but I could do side, angle. That would be the same thing. Angle, side, just wrapping around the information you're giving. And I'm going to go ahead and set this up. So we have, well, it doesn't really matter. Sine of 44 degrees over the side N is equal to sine of the 35-degree angle over 3.1 centimeters. How do you solve this? This is the setup. Solving is easy. It's just cross multiply. You'll get really good at this. So we have 3.1 times the sine of 44 degrees equals N times the sine of 35 degrees. And how do you get N by itself? You would divide by the sine of 35. So N equals 3.1 times the sine of 44 divided by the sine of 35. Do the signs cancel out? No, they do not. Do not cancel the signs. Use your calculator. Now, when you're using your calculator, you want to be pretty careful. I always recommend putting parentheses around the numerator and parentheses around the denominator just to be extra careful. This is not going to matter, actually, but just to be super duper careful. Sine of 44 divided by the sine of 35. Whoops, that would be fine. All right, 3.75. So N is approximately 3.75. And I think, pay attention to rounding. They do give you specific instructions for what to round to, and I think it's going to be to the tenths place. Since this is tenths, I imagine this will be tenths too. So we're going to say 3.8 centimeters, I think. So just pay attention to the rounding. All right, does that make sense is always a good question. Let's see. So this is a 44-degree angle. It's bigger than 35. So I would expect this side length N to be a little bigger. And 3.8 is a little bigger than 3.1. So it does make sense to me. So that seems like a good answer. All right, let's try another one. Again, it doesn't matter how you label your triangle. S, T, U. As the vertices, and then just labeling appropriately, opposite angle U is 220 centimeters. Angle T is 145 degrees. Well, clearly my triangle is not to scale. That's not 145 degrees. And angle U is 18 degrees. All right, so when I look at this triangle again, I'm seeing angle, then a side. So they've given us angle, side information. And I just need to look for those side and angle opposites. They want us to find the length of S. So length S is right here. And so, that side, I don't have that angle that's opposite it. I would need it. So how am I going to find that angle? Yes, subtract. Angle S would be 180 degrees minus the other two angles. 145 minus 18, and let's see what that is. 180 minus 45, oh, just kidding, minus 145 minus 18, and I get a 17-degree angle, very tiny, 17 degrees. So angle S is 17 degrees. Now I have that opposite angle and opposite side pair. And I have another side and angle pair. There we go. So I'm going to use those little pairs. Sine of 18 degrees over 220 centimeters would be equal to a sine of 17 degrees over S length. So if this is 18 degrees and about 220 centimeters, I would expect our 17-degree angle to have that opposite side length. So it's a tiny bit smaller. All right, let's go ahead and cross multiply. So S times the sine of 18 degrees, not 180, that's 18 degrees, equals 220 times the sine of 17 degrees. And then I can just divide the sine of 18 to the other side. I'm hoping that you can go from the setup and just do this in your head in your calculator. So I go from the setup like this, and then I just type everything in my calculator and go right to the answer. And that's totally fine in my opinion. I'm going to use this calculator now. Let's see. 220 times the sine of 17 divided by the sine of 18. There we go. 208.149 approximately. And again, I'm not sure what they're going to tell you to round to, but this is a whole number answer, so I'm going to say about 208 centimeters. So pay attention to rounding. All right. Always round at the very last step, but look at what it's asking for. Is it saying tenths or is it saying whole or thousandths? You know. Okay, so this is angle side information. Sometimes we need to figure out that third angle. That's easy to do. Last one. In triangle WXY. WXY. Side Y has length 7.8 centimeters. Angle W is 26 degrees and angle X is 76 degrees. So looking at the information that we're given, we have angle, side, angle. This is angle, side, angle information. Angle, side, angle. That's just how it's what they gave us. We want to find length W. So we need to find this length right here. W is opposite angle W. Interesting. So, well, what are we given? What do we know? What can we find out? I have two angles, so I can definitely find angle Y. That would be 180 minus the 26 degrees minus the 76 degrees. 180 minus 26 minus 76. And I get 78 degrees. All right, that's good to know. That's helpful. 78 degrees. Now I have an opposite side and angle. That's good. So I'm going to start with that. Sine of 78 degrees over 7.8 centimeters would be equivalent to sine of 26 degrees over W. We can cross multiply. So W times the sine of 78 degrees equals 7.8 times the sine of 26 degrees. Remember, this 26 is trapped inside a sine function. Can you multiply 7.8 times 26? No. This is one thing, and this is another. Don't multiply those values together. They're totally different. And then we divide by the sine of 78. So 7.8 times the sine of 26 over sine of 78 degrees. I'm pretty notorious about always making sure I have my degree symbols there because you don't want to confuse things. 7.8 times the sine of 26 divided by the sine of 78. And this turns out to be 3.49568. And looking that they rounded to the tenths place, I would assume that that would be 3.5 centimeters approximately. Again, what is the rounding? Pay attention to what they're asking for. Let's see, does it make sense? W was a very small angle, so I would expect a small side. 3.5 makes sense. It's much smaller than our 78-degree angle and the 7.8 side. So it does make sense. That seems right. Ladies and gentlemen, that's it. Law of sines is super easy. And now you can find the angles and sides of any triangle. So it basically renders SOHCAHTOA irrelevant. Hallelujah. All right, ladies and gentlemen, that's it. Have fun with Delta Math 8.2.